Hi everyone, Go to Luke here, testing a idea from a Spanish inventor or Spanish researcher about modifying a permanent magnet motor. His name is Felipe. I don't know how to pronounce his last name, so I'm not going to do it. His website is, let me see here, got it on my computer, energymev.org, and the idea here is you add a third brush in between the two normal brushes that there are on a permanent magnet motor. And that third brush, actually, ideally you'd want it to be able to be moved, and so you can change the timing of it between the two. So a normal permanent magnet motor usually has two brushes, let's say one at 6 o'clock and one at 12 o'clock, so 180 degrees from each other. And then you add this third brush at the 3 o'clock position. And now that's actually going to be now your positive brush. And your negative brush will be here at the 6 o'clock position, and at the 12 o'clock position that would be now your generator output. So that's what the claim is you can actually get a generator output while the motor is operating, and most likely not affect the motor, its motor performance or whatever. So it's basically tapping into energy that is there that you can use at free of cost. And if that is the case, I would say that's pretty big, and that's why I'm interested in replicating this and testing it. So I've used actually two pretty close to identical motors, slight differences, but they're basically razor scooter motors you can get on eBay for like 30 bucks each. That's the model number there. This motor here has not been modified. I'm just using that as a generator to create a load on this motor so that I can test it under load and see what happens. So I want to make sure this has the same performance as it does stock, and so far it's doing well. And this has a 5 ohm resistor load on it, and we're going to output a certain voltage on that, and we'll know how many watts load we're putting on this here. Now this yellow lead coming out here is my generator coil, so it is the brush that's in there that's connected there. And the reason why I use these razor scooter motors, I haven't mentioned that yet, is because right off the shelf this actually is a 4-pole motor, permanent magnet motor, meaning there are actually 4 magnet sections in there around that stator. And there are actually 4 brushes in there. So what I've done, I just disconnected one of the brush. This one I'm using as my generator output. This one here is now my positive lead, and my negative is here. So that was a really easy modification. The only thing is I have no ability to adjust the timing. But I just wanted to do a quick test and see if should see a result from that anyways. And I am seeing a result. It's like pretty much like they describe, and I'm going to power it up and show you. So for the generator output, I have a small bulb here, and basically the generator output gets more and more power output when you have a load on it. When the motor is just freely turning, it's not very much voltage basically. And most likely that may have to do as well with my motor configuration. It's not necessarily a 2-pole, it's actually a 4-pole. So that may affect the results. So it's not the ideal conditions. It'll get better probably with the 2-pole. But anyways, the effect will be seen that way anyways. So we're going to monitor the current right here at the power supply, which is off at this time, and we're going to be able to see the waveforms while it's operating. So I'm going to go ahead and start that. So now it's operating at about 12 volts, 13 volts, close to there. And 3.6 amps is what's going in, and we're delivering here on our load pretty well, 10 volts RMS. You're seeing the yellow scope data here is the output of the generator coil, so the load on that motor, and it's at 9.9 volts. And this is the voltage that's coming out of the generator side, and that is open at this time. I haven't connected that bulb, and I'm going to do that right now and show you that there is power there. And that bulb is pretty well fully lit, and I don't know if you can hear that, but there's actually a little increase in RPM when I do connect that bulb. And if we look at our scope data now, you can see that we're now actually at 10 volts RMS. So there's been a boost by adding that load from the generator side. So and if we look at our current, well, it's gone up basically 60 milliamps, and I could assure you that that 60 milliamps is actually back participating in driving more force into this. That's why the output is slightly more on the generator side. So there is a slight increase here. I'll show you. I'll disconnect that generator side bulb. It's off there. So we're at 3.6162 amps, and now I connected it, and you know, somewhere maybe like 20, 30, even 30 milliamps extra. But like I say, there's more torque happening, and that's why the voltage increases on the generator coil. I'll disconnect it now, and you can see the voltage drops on the load, and then connect it, and it goes back up. So there's a slight increase in RPM. So that is the bulb that is being lit on the generator side, and it's close to about 2 volts RMS on that bulb, which that bulb at 2.33 volts, it actually is, it would have 600 milliamps. So maybe it's somewhere around at 500 milliamps at 2.2 volts, or somewhere around there, if you want to do the math. But the important thing was to verify that if this bulb actually, or putting a load on that generator side, if it actually hinders the motor, and it doesn't. Actually, it makes it work a little more. But like I say, I think that work is basically coming from the source. But anyways, you seem to be lighting this bulb without really having any losses here. So that's a good sign. And I can show you here, if I take the resistor here off load, I'm gonna have to deposit the camera here and try to not burn myself. So I took the load off, and now you can see that the bulb actually is quite diminished, and like that's what I'm saying, that you have a better output when this is under load. Now that motor's just freely turning now, except actually it's turning the generator but with no load, and that's what the power consumption is, just to turn the device without having any load. And there is our voltage there, open coil voltage from that generator coil there, somewhere around 13 volts. And like I say, you know, you can see here that the output really diminishes. But if you put it on load, if I put my finger there and stop it, I'm burning my finger there, but you see the light coming up more. Now if I play with the voltage input, I'll decrease it here, and I'll give it a kick. See, if I just kick it, I can easily burn that bulb as well. I've actually burnt one bulb by just turning it on. So when it's under load, or when it starts, there's a tremendous amount of output going there. And from what I can see, that is actually pretty well a free lunch. So I'll connect the generator coil here, and now you see the bulb is lit. And we'll bring up the voltage there, go back to where we were about. So I think this definitely warrants more investigation, and you know, maybe modifying, definitely I would say modifying a motor that you can actually move the third brush different timings and see the total effect. Now we're operating at very low voltage compared to what they were doing. Keep that in mind. They were using 72 volt range, or motors that operate in the 70 volt range. I've been using here always around 12, 13 volts here to do the test. So I think that's about it for now. Thanks for watching. Bye.